In this example, I'm going to compute a derivative in two different ways. So one way to look at this function, g of x equals 1 over x squared times the quantity x cubed plus 3, is that it's a product of two things. So it's a product of 1 over x squared and the quantity x cubed plus 3. So I can use the product rule on this. I'll do that over here to the left. So g prime of x, I'm going to take the first piece and differentiate it. So the first piece is an x to the negative 2 if I want to look at it that way. So I could write it as negative 2x to the negative 3. Just using the power rule. Leave the second piece alone, and then you have another term where I leave the first piece alone, multiplied by the derivative of the second piece. So then I just have to sort of distribute, combine like terms, and clean things up. So I'm going to distribute 2x to the negative 3 over those two terms. I end up with a negative 2 from the first term because x to the negative 3 times x to the 3 is x to the 0, or 1. Second term, minus 6x to the negative 3. All right, the last little bit over here, this last term, x to the negative 2, when I multiply that into this, it's going to cancel the x to the 2, and I end up with just a 3 there. Combine my constants to get a 1. And rewrite 6x to the negative 3 as 6 over x cubed. And we'll put a nice box around it. All right, there's an alternative way to handle this, and the idea is to clean up the function g of x before you differentiate. So I'm going to distribute the 1 over x squared to both terms, and that leaves me, if I show some of the detail here, with an x cubed over x squared plus a 3 over x squared. And I'm going to cancel two factors of x. So g of x cleans up rather nicely to x plus 3 over x squared. Now I can get the derivative, g prime of x. And the derivative of x is 1. And 3 over x squared, well, that's 3x to the negative 2. So I'm going to have negative 2x to the negative 3 for that derivative. And then clean things up a little. That's a 1 minus 6 over x cubed. Oops. There we go. That's a lot of effort to make a box, but now I'm committed. All right, so our answers agree, and I guess the lesson here is that it's worth keeping in mind that if you see a way to clean up a function before you take a derivative, it might save you some time. It just depends on what function you're looking at.